Welcome to aminacademy.com. In physics, let us discuss about simple harmonic motion, that is SHM. Simple harmonic motion or SHM is defined as a motion in which the restoring force is directly proportional to the displacement of the body from its mean position. The direction of this restoring force is always towards the mean position. Look at this figure. An object to a spring sliding on a frictionless surface is a simple harmonic oscillator. That means this body is connected to a spring and it is pulled and released. This mass is oscillating horizontally from the mean position. When displaced from equilibrium, the object performs simple harmonic motion that has an amplitude x and a period t. This amplitude means here how much from the mean position, both extreme. The distance between both extreme is a amplitude. Now from mean position, one length is a amplitude. Time period is t. The object maximum speed occurs h passes through equilibrium. The acceleration is maximum at mean equilibrium position. The stiffer the spring is, the smaller the period. Means spring is more stiffer, it quickly oscillates. The greater the mass of the object is, a greater the time period t. The mass m and the force constant k are the only factors that affect the period and frequency of a simple harmonic motion. The period of a simple harmonic oscillator is given by here, that is time period t equal 2 pi into square root of m over k, and frequency is 1 over t, which is equal 1 over 2 pi k over m. Here capital T is a time period, f is a frequency, here m is the mass and k is the spring constant. Now we will continue further discussion. Hooke's law and simple harmonic motion. The force is a restoring force because it tends to restore the object back to its original position. That means while oscillating, the spring force wants to stop the object and come to its original position. This relationship is called the Hooke's law. That means the force is a restoring force because it tends to restore the object back to its original position. This relationship is called the Hooke's law. If a mass is attached to a spring and then displaced from its rest position and released, it will oscillate around the rest position in simple harmonic motion. That is, we can say this Hooke's law, we can say it is a F force, F is equal minus K X. You can write it here also. F equal minus Kx is a relation between force and the displacement and spring constant. Next, we can discuss about oscillatory versus periodic motion. The oscillatory motion refers to the motion in which the object moves back and forth repeatedly. That is oscillatory motion. Suppose the pendulum oscillates both ends towards the mean position is called oscillatory motion. While periodic motion refers to the motion in which the object repeats a path after regular interval of time. That is, in a regular interval of time, it repeats the same path. All oscillatory motions are periodic. All oscillatory motions are periodic, but all periodic motions are not oscillatory. Next, we will discuss further about periodic motion. A motion that repeats itself after equal intervals of time is known as periodic motion. That means it repeats continuously after particular time interval. Examples of periodic motion. A tuning fork or motion of a pendulum. If you analyze the motion, you will find that the pendulum passes through the mean position only after a definite interval of time. That means each oscillation it takes same time. We can also classify the above motion to be oscillatory. An oscillatory is a motion in which the body moves to and fro about a fixed position. So an oscillatory motion can be periodic, but it is not necessary to always. So taking an example of a wave motion, we will see some parameters related to periodic motion. Let's take the following figure. Look at here. Here this is the displacement. This is a time axis. Now look at this. Here this is a sine curve. Here this from the point A is top position, and another way the next position of the top is B. So distance between them is time period. Here here this is the height, this is the amplitude. Now periodic motion formula. First we will derive time period. What is time period? We will define. It is the time taken by the motion to repeat itself. So the unit of the time period is second. So here the point starts from here to come here and come to this. This reaches same position. That means this position and this position is same position. Like this A and B is the same position. Time taken to it is the time taken by the motion to repeat itself. That means from here start and from here then it start repeat. So the time from here to here is called a time period of this wave motion. Frequency. It is defined as a number of times the motion is repeated in 1 second. Here the waves continues. In 1 second, how many such a wave is passing through is called a frequency. Further you can see it is defined as a number of times the motion is repeated in 1 second. The unit of frequency is Hertz. Hz. Frequency is related to time period as frequency is 1 over T. This is the above is the formula used for periodic motion. Here we will further discuss. Here look, Newton's first law implies that an object oscillating back and forth is experiencing forces. Without force, the object would move in a straight line and a constant speed rather than oscillate. Consider, for example, plucking a plastic ruler to the left here. That suppose you are fixing one end of the plastic ruler and give the force to other end, it's vibrate. The deformation of the ruler creates the force in the opposite direction known as restoring force. Once released, the restoring force causes the ruler to move back towards its stable equilibrium position, where the net force on it is zero. However, by the time the ruler gets there, it gains momentum and continues to move to the right, produces the opposite deformation. It is then forced to the left back through the equilibrium, like it continues. That is, therefore, the formula says F equal to minus Kx. This is the Hooke's law, which describes and applies to the simplest case of an oscillation, known as simple harmonic motion. That means there is a direct connection between Hooke's law and simple harmonic motion. In further discussion, we will discuss in future videos. We have done. Please subscribe our YouTube channel.